consists of your DC I out. DC I out is 9.16 milli plus 0.62 milli, sorry, 62 milli divided by 5.92 ohm and sine omega t. Okay, so you have your AC and DC term. All right. Any question? Any question? No question? This is the time right now is mid-afternoon. Mid-afternoon is the worst time. Right? Your eyelid is very heavy. It's like tons. You're trying to keep your eyelid open. Alright, so I understand because me standing up here facing that problem as well. So, okay, so anyway, let's keep this thing going on. Alright, any question? No? Let's look at question 3. In question 3, we have 4 parts. Right, we have 4 parts. Part A, part B, part C, and part D. The 4 parts are basically just doing a combination, a permutation of 2 resistor, 2 diodes, and 2 supply. All right, with ground as well. So these are the 4 components. You have 2 resistor, 2 diodes, connected in different combinations. So the first question here is with 10 volt minus 15 volt. The 2 resistors are both 15K, and the 2 diodes D1 and D2 are connected in this direction here that you have here. Right? So in order to solve this, we must first make some assumption. We first, in this particular case, assume that both the diodes are conducting. Here, we are treating the diode as simple diode model, which means to say when it turns on, the voltage is fixed. When it turns off, it is open circuit. Alright, so this is what we're going to base on. So here, if we assume that both are conducting, then we take the datum H here, which is ground. So this is 0 volt. And for this diode to turn on, the voltage at this node will be plus 0.75 volts. Okay? And for D2 to be conducting, it will drop 0.75, and therefore the voltage here is 0. Go up by 0.75, go down by 0.75, you're back down to 0 volt now. So therefore, if this point is 0 volt, this is minus 15, you have a voltage drop across the 15K or 15 volt divided by 15K, you get the current that is flowing in this direction, and this current is 1 milliampere of current flowing. Correct? 15 volt, 15K, you get 1 milliampere flowing from D2 towards the negative supply minus 15. And when the current flow in this direction, it actually flows from anode to cathode. So therefore, it is forward bias for D2. Let's take a look at D1. In order to find out D1, let's take a look at the current that's flowing through the resistor at the top. We know that one end of the resistor is connected to 0.75, the other end is at 10 volts. So a total voltage of 9.25 drop across this resistor 15K. Divided by 15K, you get the current. So this current that's flowing is less than 0.66, is less than 2/3 of a milliampere. So this current is probably about 0.6 milliamp. And the current that's flowing through the lower branch here is 1 milliamp. So we need to supplement, because this current from the top is lesser than the current that's going to the negative supply. So we need to supplement some current from another branch. So this supplement has to flow up through D1 in order to supplement the current that's flowing here. Alright? So therefore, in order for this current to flow through D1 from ground or from the cathode to the anode, it implies that D1 would be reverse bias. Alright? So our first assumption that both are forward bias is wrong. Only D2 is forward bias and D1 is reverse bias. And because of this, we can now rewrite this or redraw this circuit, and this circuit now becomes like this. Because only D2 is conducting, D1 is off, so we can remove D1 from the circuit, treat it as open circuit, and therefore only D2 appears in your circuit with your two resistors now. And based on this, we can find out the current that's flowing here, which is ID2. So ID2 is equal to the difference between the two power supply, 10 volt minus 15 volt, minus the voltage drop across the diode, which is 0.75, divided by the remaining resistor 15K plus 15K, and that works out to be 25 minus 0.75, that will be 25.25 volt divided by 30K, and that works out to be a current that is given by 8.8, or rather 0.808 milliampere. And therefore we can write the Q point. The Q point for D2 is having a current of 0.808 milli and a voltage drop of 0.75 volt. And for D1, because it's reverse bias, there is no current flowing. Voltage drop across it is the voltage at this node with respect to ground. The voltage at this node is the voltage at this node with respect to ground. And this voltage with respect to ground, because with respect to ground means the voltage across this diode is 10 volt. So this point here is 10 volt minus the voltage drop across the 15K. The current that's flowing through is 0.808 milli multiplied by 15K gives you the voltage across the resistor, and therefore this is your ID1. Happens to be 2.13 volt with a minus V. So the voltage drop across the diode is a negative value of minus 2.13, which indicate that it is reverse bias, right? Alright, so that gives you the Q point of D2. Any question? Any question? Seems like the eyelid is getting heavier. Almost falling asleep. You are almost sleeping now. My voice is hypnotizing you. By the snap of my finger, please wake up. No sound. No wonder you cannot wake up. Okay, let's take a look at part B. In part B, we are this. $10 volt plus 15 volt. Alright, we have D2 here. This is going to ground D1. Alright, this is 15K as well. Alright, 15K. Alright, so again, by the same way of analyzing this, we say that both diodes are conducting. Alright, and therefore, if both diodes are conducting, I expect the voltage here to be plus 0.75 volt. And if this is forward bias and this is also forward bias, I expect this to be 0 volt. Alright, if we have 0 volt here and minus 10 volt, you have 10 volt across 15K, and we're going to have a current that's flowing here given by 10 volt divided by 15K, and this gives you 0.66 milliampere flowing down towards the negative 10 volt supply. Alright, so let's take a look at the current flowing through this other resistor. Now, current flowing through this resistor, having a 0.75 volt drop at this node, you would have 14.25 volt drop across this resistor divided by 15K. That will be the current flowing in this branch. Now, this current that's flowing through this branch is more than 0.9 milliamp, because this is 14.25 over 15K, very close to 15. So that current will be 0.9 something milliampere. The current that's flowing down to the negative supply is only 0.66. So the difference in that is a current in excessive of it. So realize, because of this excess current, the excess is going to flow through D1. And therefore, our first assumption that both diodes are conducting is correct. And therefore, we can now evaluate the Q point again. So the Q point of D1, or make it D2 first, D2 will be a current of 0.66 milli flowing through D2, and a voltage of 0.75 volt across the anode to cathode of your D2. So what about D1? So for D1, the current will be the difference between these two currents. Right? So so this current here will be 14.25 over 15K minus 0.66 milli, and that will be the current over there. The voltage drop is the same, because when it conducts with a voltage drop of 0.75. So that will be your current that's flowing there. And if you work it out, this value is 0.283 milliampere. And this is ID1. Okay? Any question? Any question? All right. Now let's look at part C. All right. In part C, we have this. Reflect the diode. Again, we assume that both the diode D1 and D2 are conducting first. And if they are conducting, then D1 will have a positive 0.75 volt drop across D1, having the anode to be more positive than that of the cathode by 0.75, which means that if the anode is at 0, the cathode will have to be at minus 0.75. Alright? And that also implies that if D2 is conducting, then the anode and cathode difference will still be 0.75, which implies that the voltage at the cathode will be more negative than the anode by another 0.75. That means that the voltage at this node is 1.5 volt minus. Alright? So if the voltage at that node is minus 0.75, then you have a total voltage drop here that is equal to 13.5 volt.